Hey everyone, thank you so much for watching another episode of the Weaviate podcast. I'm once again super excited to be joined by Weaviate co-founder and CEO Bob Van Vinod and welcoming a super exciting guest, Vinod Valloppillil. Vinod has one of the most impressive resumes I've ever seen, met someone this accomplished in the technology industry. Google, Dropbox, Microsoft, startups, and all these things. Vinod, it's such an honor to have you as a part of the Weaviate team as an advisor, and of course today on the Weaviate podcast. Thank you so much for joining.
Absolutely, glad to be here, and can't wait to talk more about the future of vector databases and LLMs. So.
Yeah, great to have you here, Vinod. It's I think we're introduced. Maybe it was like a year ago or something, or
something I would say like maybe a year and a half ago. Through like some fellow entrepreneurs and stuff. Yeah.
Exactly. And one of the things was the so of course, as a co-founder in my role, you're constantly thinking of like, okay, how does our business evolve, right? So we have this beautiful thing we do that's, as I always tell people, it's like if you peel off the onion, you find in the center of the onion, you'll find the index, which is that's the vector index, but then the whole onion sits around that, right? That goes into like, how the product evolves and how we help, as I always like to say, how we help people be successful with LLMs. And it's wonderful, to work with you, Vinod. And I think it's great if people, hear a little bit like how you think and those kind of things, and maybe it helps them. Maybe it helps them also to create stuff with Weaviate. So that's great. But there's one question that I really want to start with, Vinod. Can you share maybe with the listeners what's an Halloween document?
Yeah, that was from many moons ago. So I started my career at Microsoft a long time ago in the early days of Windows NT Server, and so on. And then the Halloween document is over 20 years old, I guess, at this point. And what it was, it was an interesting piece of computing history. I mean, it was basically at that time, Linux was just starting to appear on people's radars. And so a bunch of the Microsoft executives kind of tasked me with, hey, go figure out what this Linux thing's about and start figuring out, is this something Microsoft needs to worry about, and what are we going to do about it, and so on. And so, the Halloween document was kind of the first of a series of kind of internal memos and internal investigations about, just kind of educating Microsoft internally about, hey, what's this open source thing? What's this Linux thing? And so on. It was kind of controversial. It was kind of interesting because it kind of, it was always designed for kind of internal consumption inside of Microsoft, and through whatever set of paths it ended up getting leaked out to the outside world, it generated a lot of interesting commentary and reaction. But I think, I don't know. I mean, in hindsight, I think most of what the documents were kind of describing and, kind of observing held true. I think they survived the test of time. And in fact, I was just talking with somebody else in Microsoft, and they were talking about how if you look at Microsoft Azure, the cloud computing services, it's now actually one of the world's largest deployments of the Linux operating system. And many of the advantages and kind of intrinsic benefits of open source proved out to be true. Like, it's very hard to imagine building any kind of new developer platform or developer service today without a substantial open source component.
Can you? So what's interesting, because I when we just were in the green room, I guess, before we started to record, I believe because the documents are in '98, I believe, and I believe. How old were you again, Connor? What was it again in '98?
23 years old, 22 years old. Yeah.
yeah. So. And Connor, here we go, 2 yeyears old. I was a little bit older, but what's interesting is that, especially by the end of last year, right? So it's now early 2024. The role of open source in AI in general, with the LLMs, with the methodologies, databases, and I want to get to that. But the role of open source is such a even when I started my career, open source was such it was everywhere. So it was like a no-brainer to work with it. Can you maybe, just for people listening, I think it would be interesting. So apparently from these documents, that was not the case, in halfway through the 90s and probably before that. What was it that changed, that importance came into for open source, that also, so money went into open source and those kind of things? Was that was that already established in '98, or was that still on the forefront, that people weren't sure yet what direction it would take? And I would love to understand what was the big change? What was the change? Was it like in infrastructure, in databases, in companies
Sure.
that you were like, yes, what we wrote in these documents, the whole open source thing, that's here to stay. That's not going to go away.
Yeah.
When was that?
Oh no! I mean, I think the most fundamental driver on the open source, and this is actually something we touched on in the Halloween memos way back in the day. At the end of the day, the most fundamental driver is the internet itself. Right? The internet vastly grew the total computing universe, vastly grew the number of people who are interested and willing to contribute even small slices of their time to an open source project, and then provided this interesting, unique collaborative framework for kind of stitching together all these little tiny slices of time into a cohesive product. I mean, if you're asked, like, the vast majority of the history of computing, I mean, this is, even work from home is kind of a newish thing, or was an internet-enabled thing. The vast majority of the history of computing was, dozens or hundreds of people all in the same physical location, coordinating together. And because they're all in the same physical location, they're all employed by the same company. They're all building something under, on the company's clock, on the company's dime, in the company's facilities, inside of a single company repo, and so on. The internet blew up a lot of those, or it provided an alternative, I should say, to a lot of those assumptions, right? It meant that now you can have a large distributed network, globally distributed network of people, many of whom were doing, contributing volunteer cycles. And so, I don't know, there's maybe about 3 or 4 kind of different variables that all change at the same time, right? Maybe I'll go back to one of the biggest ones is the total market for software and computing devices grew astronomically. And it wasn't, in the 80s, 90s, and even in the early 2000s eras of computing, if you weren't monetizing the vast majority of your software installs, you were on a path to bankruptcy as a company, right? They just literally, the total number of installs of a database or whatever might be measured into tens of thousands or hundreds of thousands. And so as a firm trying to pay salaries and so on, you need to make sure you're monetizing half, if not more, right? The vast majority of those installations. We're now in a world, especially in with software and especially infrastructure software, things like databases, things like operating systems, and so on, where you only need to monetize a tiny percentage, 1%, 2%, 5% of the total installed base in order to run a viable, ongoing concern that can provide support, product roadmaps, product evolution, and so on. And so that radical shift, right, in the numerator, right, that radical shift in the total addressable market of software meant that business models that only monetized 5% of their installed base were suddenly viable, whereas a few decades ago it was completely impossible.
Yeah, that's super interesting, and that's an interesting fast forward to today, because I would love to first double click from that perspective on models, right? So I mean, it doesn't have to be LLMs per se, but we can take LLMs as an example. And one of my, I guess, like hobby horses, if you will, things that I like to talk about. There's a blog post about this in the making, by the way, is that I'm fascinated about the fact that the companies creating businesses around machine learning models have to deal with the fact that the models today are stateless. And quickly, for the people listening who don't know the background story, so very quickly to go over that. So for a long time, when we're building, for example, infrastructure and those kind of things, the thing that we monetized was statefulness, right? So you store something in, for example, a database, or you have something go through like a streaming Kafka thing or whatever, right? The thing you want to, the state was involved, right? So if you shut down a database, or if you stored something in a database, then 3 days later you were still hoping that it was there, and that's kind of what you're paying for, and that kind of now is separated in storage and compute, or combination of both, or those kind of things. What I found fascinating about LLMs is that LLMs don't have that. So let's say for example, when OpenAI released GPT 3.5 as a behind an API, and people saw that value, then that was kind of the only business that they had, because the model has the same problem as I always like to say as an MP3 file, is that it's great if you make a beautiful song, and I might be paying for that one MP3 file, but if you go like, hey, Connor, if this is a beautiful MP3 file, I share it with you guys, you enjoy the music too, you're probably not paying for it, right? Because there's no state involved. So a way to do that is the, quote unquote, Spotify model, which we now see with LLMs. There's a Spotify model. To get access to that LLM, you can't get access to the raw thing, but it's behind a paywall. And with the working assumption that that's not going to change, that for the foreseeable futures, the models will stay stateless, I find that fascinating because now people need to think different about how to build, a business around these kind of models, because not every company is able, that can be for security, privacy, latency reasons, whatever, get that information from behind a API-based walled garden, if you will. I would love to hear your thought. Yeah, sorry, go ahead. Yeah.
I was going to say, I might actually push back a little bit on that. I'm not sure if I'd call the model stateless. And I think it might actually be, it's potentially even a worse situation than a stateless model, right? So I've been working in different AI systems. My first computer vision startup and stuff was maybe, I don't know, 10 years ago, I guess, at this point. And so much of the era, of the, there's kind of classical AI with like symbolic systems and so on. Then kind of deep learning kind of showed up about 10 years ago, roughly, and it kind of revolutionized all, the language and the vision and so on fields. And in the early days of deep learning, it was all about searching for the right algorithms to feed proprietary data sets into. I think the big thing that happened with LLMs, what OpenAI kind of really proved by putting cool stuff out in the market, 3 or 4 years ago, was, in the past, AI development was grab somebody else's model or grab somebody else's algorithm and bring your data. With OpenAI and GPTs and so on, it became, hey, we're going to go scour all the data in the world, right? We're going to grab as much internet data as we can, and we're going to give you a whole bunch of data that's prepackaged into a model. And that data, unfortunately, for better and worse, there's pros and cons, is opaque to me as a model user or me as a model consumer. And so it's a highly stateful model, but the risk is that it's frozen and you have no idea what state was fed into that model from the outset. And so things like hallucination or things like jailbreaking and so on are outcomes of the fact that we ultimately don't really, especially a large commercial model, we ultimately don't know what was used to bake that model. And so God only knows what weird prompt we can throw at it that'll create it to, that'll force it to regurgitate this crazy training data that it was built on. And so for a typical enterprise, it's a highly stateful thing, but a highly black box, right? It forces you in a certain corner.
Yeah. So would it be fair to say, if we want to stick with the MP3 metaphor or analogy?
I mean, it's an MP3 that has 100 songs pre-baked, right? And you're trying to figure out where to skip inside of an MP3 to get that song, right?
Exactly. Or maybe another way to look at it is that the so if you have an MP3, in the way that's different is that the MP3 file. I mean, if there's a baseline in there, right? We can't change the baseline, but in theory, in the model we can change the baseline, but it's a black box. It's hard to figure out how to change specifically the baseline and not by accident the piano, right? So how can we label that somehow? How could we call that? Is that what kind of state is that? So we have pure stateless, pure stateful. It's somewhere in the middle, I guess.
The phrase I've often used is that it's pre-baked. It's knowledge that somebody else grabbed and somebody else kind of wrapped into the model, giving you a baked system.
Yeah, but this is actually interesting, because if you have these three types, right? So the with everything that now came into the cloud, and when it comes especially to the business around that, the people kind of figured out how to build businesses around pure statefulness, databases, infrastructure, that kind of stuff. On the other hand, we have the pure stateless solution, so more on the consumer end. I'm thinking, Spotify, those kind of things. So would you argue that this third new way, let's go with the label pre-baked, opens up the door for like a completely new way of creating value and capturing value?
Absolutely, right. I mean, in especially with both of you guys have an AI background. Like, I mean, the old days of AI development, and I think Andrew Ng has a lot of really nice talks that he's given out on this, right? In classical AI development, it was a multi-month, right? 3, 6, 9 month process to get data, prep data, clean data, test the model, build a model, throw it out there, and then see what works. when you have a pre-baked model, when you have an LLM that already has all this knowledge, pre-installed into the model, it now becomes, a multi-week, maybe weeks or months process to just figure out the right incantation, right, the right prompt to throw at this baked model in order to get the right output out. And so you've dramatically shortened the time to value, right? The time to actually get something out of an LLM that you were looking for, as well as dramatically broaden the audience of people who are now able to interact with the LLM. Right? You don't need an AI master or AI PhD in order to get an LLM to do something for you.
Exactly, and where do you think, especially now what we see with something like RAG, which is the reason it's so interesting, if we, besides the academic side of it, right? So the how do we do it, besides the new use cases that come out of it, but if we look at it from more the value creation or the business side, if you will, how do you see that evolve? What do you think what will happen? Because of course, and I'm this is a little bit the self-serving question, of course, because we have the vector database that we weave together with the models. What are your thoughts on that? How do you think that will that develop? And do you think that open source plays a role in that? So I would love to hear your thoughts on that.
Sure. Yeah, no, I mean, I'm definitely obviously on multiple levels and have been for a few years now, a big believer in all forms of retrieval augmented generation. Even before it was kind of called retrieval augmented generation. There was a paper that DeepMind put out maybe 3 or 4 years ago that I was a big fan of, and I remember reading the paper back when I was at Google on a project they called Retro. And Retro's goal was retrieval enhanced transformers or something like that. And Retro's goal, or one of the big findings of Retro, which was one of the many advantages of what we now call RAG, but one of the big observations on Retro was that if you minimize the amount of data that's packed into the model's own parameters, what's called parametric memory, and rely on external retrieval to an external database, you can end up with something like a 25x smaller model delivering the same performance or the same value as, in that case, 175 billion parameter GPT-3. Retro's goal, once again, was they were pushing kind of the theoretical extreme to figure out what's the smallest possible model you can build when you have when you can guarantee that it's always going to be augmented by a database. But even that, right, just that one issue of model size has dramatic advantages when it comes to developer ergonomics, right? A 25x smaller model literally is multiple times easier to build and deploy and train and retrain and fine tune and so on. And that's before you get into all the other advantages of a retrieval augmented system, right? A retrieval augmented system, you can now independently update the data without having to update the model weights. The data can be kept fresh. There's a lot of evidence, and some of the guys at Facebook and Facebook AI Research in their paper that coined the term RAG, they also cited a whole bunch of other advantages around things like hallucination, hallucination and being able to keep the model instead of a guardrail when you have really tight coupling between the model and the database. I think it's kind of inevitable. Like in my case, I think, if I were to look at how would I chart this, the industry's pendulum swings and so on, is, maybe the first 2 or 3 years, up until 2023 of large language models, a lot of the goal was basically how do you pack as much knowledge into the parametric memory, into the parameters of the model as possible in order to deliver the biggest and baddest and craziest pre-baked model. I think a lot of what's going on in 2024 is people are starting to back off now from a really simplistic view that a bigger model is better. And so now you're starting to see alternate model architectures like Mixtral, was really hot with their mixture of experts. You're starting to see RAG really become part of the mainstream conversation on models. I also think we're not far from seeing a lot more AI that's specifically optimized or specifically targeting the idea that every LLM will be paired with some form of external non-parametric memory over time.
Yeah. And do you think, this is great, by the way, and so do you think so? In a previous podcast, we had a conversation with Paul Groth, where we talked about like knowledge bases, knowledge stores, those kind of things. And also he comes, of course, more from an academic perspective. But one of the things that we try to determine, and that we were just fantasizing on the podcast, like what the direction could this go into, right? And because the fascination that I have is like that these weights that they sit like just in a binary blob, right? So what do you think? Would this are we going to go to systems that are more storing and manipulating these weights in near real time, or is it just still going to be a different system? Are we going to do that with vector embeddings? What do
Yeah.
you think? What
Yeah,
is
no,
what do
I
you
think
think?
this is a very rich topic, and there are a lot. I mean, large teams of researchers spending millions of dollars trying to explore all the different corners of this particular universe. I mean, maybe that's a good thing we can drill into a little bit. Like, I think there's, I know, order of magnitude 4 or 5 different paths that this industry is kind of walking down right now.
Hmm.
Up until let's say the circa 2023 and before path was a really rich framework, a Lang chain or or Llama index, Haystack, and so on. A really rich framework that was managing the retrieval stack, and so encoding content for proper retrieval, pulling content out of the vector database, and encoding that content into a prompt, right, in context learning against a large language model, and using that to drive language model behavior. That architecture is a reaction to the fact that the language model itself is pre-baked and very, very high function. The language model doesn't really care about the fact, at least in this version of the architecture, the language model never really cared about the fact that there was a retrieval system that was part of the game. And a lot of what you were doing was trying to make this retrieval system matter to the language model in the form of in-context learning. I think a lot of a lot of the directions and explorations that people are pursuing moving forward go on 4 or 5 different tracks. And the one you were kind of hinting at, Bob, is that there is one angle which is basically let's revisit the assumption that the language model itself has to be or should be frozen. What are there ways that we can directly edit the parametric memory of the language model to add facts, delete facts, and so on? I think there were a couple papers where they change the capital of France or whatever to Pittsburgh or something in order to make demonstrations of that, right? And I think there's early research progress on that. It's still a long way to go before we really achieve anywhere near the production level capability that we've already started to see with frozen language models, or even more classical techniques like fine tuning or kind of training your own model. If you other directions that we're starting to see a lot of investment in is basically a much richer retrieval stack. And so, you guys just had Omar Khattab and Colbert on, where we're talking about if you assume that the retrieval layer is doing a lot more semantic understanding of the content. It's not just simply getting and putting vectors, but also doing things like BM25, so it's actually got an inverted text index as well as a vector store. And then you take another level up where you say, what if the retrieval stack is actually a model in and of its own right? You end up with much richer retrieval mechanisms that can now be fed into in-context learning and then ultimately into a model and sent out. Another entire different direction, and this is the direction that the Facebook team was originally, or the Meta team was originally pursuing when they did what they called retrieval augmented generation, is what happens if you co-train a language model alongside a retrieval model. And so, RAG and Retro and so on looked, they were building out variations of both systems, right? They weren't holding one thing fixed. They were co-training both systems for maximum performance. There's a bunch of advantages from that, right? At the end of the day, in almost all machine learning systems, end-to-end training wins it all, right? However, there's a lot more to this world and a lot more commercial reality to this world than just being able to. Not everybody has the ability or the desire or the interest in training their own custom language model optimized for a particular retrieval stack. Or a particular retrieval set. And so it'll be interesting to see how that evolves. I mean, maybe we reduce the cost on that, or maybe it becomes an interesting thing moving forward. There's also a lot of interest, or another angle that we're seeing a lot of is basically if you look at a lot of what's going on in retrieval augmented generation, a lot of the demos of retrieval augmented generation, they're basically just smarter forms of search. You're not
Yes.
asking the model to take the retrieved content and then generate Shakespeare with it, or take the retrieved content and turn it into an algebra lesson. Right. A lot of the times, what you're doing is you're asking the model, "Hey, just summarize what are the top 2 or 3 issues or top 2 or 3 findings in this research paper." Um, if the surface area that you're looking for from the language model is that small, right? It's basically things like text summarization, or kind of weaving a cohesive piece of text across the findings across 2 or 3 different retrieved blobs. You don't need the full capabilities of GPT-3, GPT-4, and whatever to do that, right? You end up with a much smaller language model on top of a comparatively much richer retrieval system or retrieval model. And so those are a couple of examples, right? And there's maybe like 2 or 3 cases that are still out there. For example, another one that comes to mind, just because I was pretty involved with it at Google, is much more formal knowledge representation. And so things like knowledge graphs as the basis of retrieval, rather than text blobs as the basis of retrieval. And so I think, a lot of what I'm kind of looking forward to in 2024 and beyond is kind of seeing how each of these different threads play out. All right. I think
Yeah.
the desire and the need for memory augmentation that's outside of the model is very clear, very, very strong. The question is going to be, how does it play into model architectures moving forward?
Yeah, and I think so. Connor, didn't you also do some paper reviews on that specific topic, right? I believe that isn't that MemGPT also a way to achieve that, or am I off there?
Well, I think MemGPT is kind of about. So I kind of took the end of what you're saying, Vinod. It kind of inspired me thinking about like how we had a lot of extractive question answering models, like trained on the Squad data set, for example, and that offers a pretty cool functionality where you can like retrieve search results and then highlight the most relevant things. And we have all sorts of tasks like say summarization or text to SQL that do that kind of like specific task. And I think now what's different more than anything else is we have these models that can produce training data for task specific models, and then we can fine tune them to the smaller specialized thing and all these use cases. But I think where it maybe connects with MemGPT is it kind of connects with I think it might help the context to know that MemGPT is kind of related with Gorilla as well. In that Berkeley lab, you have Shashir Patel also on the paper with Charles Packer and others. And so I was trying to make
I think there is a lot of fruit, and you can model the retrieval stack as basically yet another tool inside of a tool former, inside of a tool, a tool understanding or tool using LLM.
Yeah.
And sorry, go ahead, Connor. Sorry. Yeah.
Oh no, so I was just going to say, like, agreeing, like this whole use a specific tool and train a model for one tool. I like that you brought up tools former a lot too. That's a really cool.
Yeah. Yeah, and what I find very interesting is that I think that and I have to admit that I have some hopes for it, and can give some context to why. But that the last point that you made, related more to knowledge graphs and those kind of things, that I hope that we now see this reg use case and that's playing out and people know what it is. It's it's today still primitive, right? How we do it, but it already creates a lot of value for people, right? So we kind of can see where that's going in the research and how we're contributing from the database perspective. But I'm really I hope that that after reg that we can start looking at the knowledge graphs, because it's also what I see online, what people are doing. I was very happy with that, because I'm not sure if people listen know, but actually the beginning with Weaviate was using the embeddings, and this is pre LLM. This is way back. This was with the graph models. I was like trying to solve the fuzzy relations in knowledge graphs. Well, where we couldn't make them, because I thought, like, it's a back then the whole semantic web, etc., was like a big thing, and I was like, hey, maybe this is a way in linked data to make these relations. So it's kind of nice to now see that come back. And we're even looking into, can we store the complete representation, the knowledge graph representation, so including the weights, for example, in a graph connection, can we actually represent that in vector space, right? So we can basically traverse the space. And for people listening, a way to think about it or to visualize it is, as I always say, is like a knowledge graph today is like a thing is like that lives in 2D, right? So it's you can draw it on a paper and you can say, I don't know, Bob lives in Amsterdam, right? And that's like how we can make relations. Or if you want to have weights in there, the distance between Bob and New York is, I don't know how many miles, but that you can fill it in. And I think we can kind of capture that, or not kind of, I think we can capture that also in vector space, and the models can help us move stuff around in vector space. So if that's true, and if that people start to adopt that would be amazing, because that would be like another big unique use case also for vector databases, right? So
Yeah.
I'm very, very, very eager to, and then also what the team is doing, explore that further and help people to build these kind of systems. Because also the thing is like a graph is often complex also to traverse, and especially to build the infrastructure. I mean, I know that from friends working on graph databases, right? So if you can represent that in vector space, that would be amazing, because it at least becomes significantly easier to traverse a vector space than the traditional graph. So,
Yeah.
but
I mean, I definitely have a couple of reactions to that. It's like, I mean, I think,
yeah,
I mean, so I've spent a fair amount of time in like enterprise search as well, and so the classic, the classic thing, or the classic marketing problem that everybody has in enterprise search is they're like, how come searching my own internal data set inside of my company, why is it so much harder than searching on Google? How come everything I see on Google just looks so much better? And the kind of the dirty little secret of a lot of that is that at the end of the day, part of the reason that Google search works better, obviously they've invested a lot of money and people and energy into that. But part of it is also because the underlying content on the web is actually much higher quality content, right? People have similarly invested decades in creating the world's best possible landing page that answers specific questions, and and professional graphics and professional content, describing these individual topics, because the web is so large. By contrast, a lot of the content that lives inside of corporate intranets, or a lot of these private data sets, there just simply is nowhere near the level of directed investment around creating the highest possible quality content corpus. And so, in classic enterprise search, the problem is no matter how good your search system was, you're always at the end of the day, you're always beholden to what was the underlying content quality. I think you have a similar problem with RAG, and the industry as a whole. We're moving from crawl to walk, right? These are version 3, version 5 kind of problems, but we're not far from hitting. We'll soon see a wall where a lot of the problems that we have with the RAG is that the underlying content itself is kind of messy and so on. And a lot of that stems from the fact that at the end of the day, text is a very lossy way of representing information. And so I think there will be a resurgence of interest, or resurgence, a goal to basically mimic what Google had to do on the public consumer web, is find much more formal, deterministic, explicit representations of knowledge that can be much more directly manipulated by machine. I mean, there was a paper just on maybe a month ago, and LLM space moves so fast, right? But I think it was just a month ago, talking about the reversibility curse in LLMs,
yeah,
where if you asked the question about who is Tom Cruise's mother, it got it right. But if you said, so and so, who is so and so's son, the LLM had no idea. And it's a perfect example of where this implicit knowledge representation, just trained off of text, leads you into the kind of these weird error cases. And it was kind of funny because that was almost exactly, or almost precisely, a textbook 101 example of something that a knowledge graph can trivially conquer, right? A formal representation could absolutely tell you, so-and-so's mother is therefore so-and-so's son, right? And so I do think there is ultimately going to be some more convergence, or some more connection between much more formal representations of knowledge and then the highly implicit representations of knowledge that you have that are inside of the weights of an LLM.
Yeah,
yeah.
if I can, sorry.
No, go ahead. Go ahead.
I can add one quick nugget. I met with Kevin Mang, who's the first author of Mehmet from MIT, and I think he gives a great example of this reversal curse thing where, so it's, as Bob's mentioned, you change LeBron James plays basketball to LeBron James plays football, and then you ask it, who was Kyrie Irving's teammate when they won the championship? So it's like, how do you resolve these other, dependencies in the knowledge? I find that to be like a
Yeah.
great, on this implicit, explicit.
I never thought about it like that. That's a good one. That's a good one. Yeah, it's fascinating because it kind of assumes that everything around it, and you get into this very complex recursive thing where you just basically need to you're basically creating another world, right? So
Yep.
the model has a world representation, and you're basically saying like it's a different it's a different world. So and then before you know it, we end up in analytical philosophy. So let's be careful with that one. But the with all those different world representations. But that's a good one. It's more like then the model is at where we are right now. What we know is like it's more like a companion, right, to help you search. What I also find interesting was I find the human element in this interesting as well. And what I mean with that is that people will take the path of least friction. So I remember. So for example, you could argue that if you have the web and the fact that we express web pages in HTML, um, um, let's forget about Flash and stuff for now, but just that we have a HTML representation, a DOM representation of information on the page, right? And that a search engine like Google can parse that kind of information and work with it. That's actually, it's kind of understandable why that works, because if you look at the common crawl, for example, who is also parsing that information that then in turn is being used. By the way, I think that the common crawl is an example of one of the unsung heroes of all these models that are being trained. So if these people are listening,
and the
shout out.
Lion data set as well. I mean, all the images.
Exactly.
Yeah.
Exactly. I believe that I might be completely wrong. So if I am, then my apologies. But I think that the common crawl team is like 2 people or something. It's like it's a very tiny group. But the way that they can also store that information in these huge WARC files, and that they get that from HTML structure, that kind of shows already that that's possible. And I also remember what I found fascinating was that I remember when microdata became part of the HTML syntax. So basically, that you could say, right, okay, if I say this pair of Adidas shoes is, I don't know, $150, that you could say like Adidas refers to or Adidas, as they say in the US, refers to to a brand, and then $150 is then the price. And what was funny was that I spoke to, I guess, an expert on the semantic web, so the microdata semantic web, kind of same thing, I guess. The that he told me, he said, what's so interesting is that people only tag it properly if it's in their own interest. So they're not going to go to lengths to actually tell you that Adidas is the brand, but they're happily tell you that it's $150 because then it shows up in like the shopping feature. So, and the reason I bring this up is because what I find so interesting is that one of the things that these LLMs, let's stick with language for now because it's easier, what these LLMs do is that they also take a lot of friction away from how we can parse information. And yes, not everything yet. So the PowerPoints are still difficult and that kind of stuff, but it takes away the friction to build stuff. And this is something that goes back to the conversation that we had with John Maeda here on the podcast. Is that one of the things that excites me so much about this is that it's becoming less elite to build these kinds of systems and tools. Yeah. So I love the fact that people now with a prompt or with a little bit of Python can start to build new products and things, right? So, and that is a really cool thing. So the point I'm trying to make here is that that I believe that that this paradigm shift is happening from formal data, as we also do it in knowledge graphs, to more fuzzy data, I guess, or informal relationships that we don't even, that the model just infers for you. And I think that is like tremendously exciting. So it just becomes easier to build stuff, right? So, and that's something that I'm also very excited about. So, and
I mean, at the end of the day, humans. At the end of the day, humans do not do formal logic when we communicate, right? Like human communication, human visual, verbal, and so on is all fuzzy, unstructured data, and in our brains, we try to kind of create a formal system around that. And so the vast majority of the content is out there to train on. At least the human-generated part of it is going to always be that way. And so LLMs. Yeah, I mean, the pursuit of formal representation of knowledge, I mean, there's no question that machines need that formal representation, at least today. LLMs kind of crack that open a little bit. I mean, the classic problem in your Adidas example is, the classic problem with formal representations is, at least to date, right, that Google Knowledge Graph being a great example, it is an insane, like thousands upon thousands of people of investment to kind of construct and maintain those knowledge graphs, or construct and maintain those formal representations. The hope is that LLMs dramatically reduce the cost and ongoing, the initial construction costs and ongoing maintenance of a knowledge graph, and make it something that brings it within reach. I mean, there's obviously a ton of research going to this right now, and we'll see what they're able to pull off. It's definitely hopeful, right? This is the first significant opportunity in this category in a few years.
Yeah, exactly. And the and of course, also things related to what we're seeing now with multimodality, right? So I had a conversation with I believe it was actually with I met up with Niels Reimers, and I think that he explained to me a very simple problem that he was working on or something. That he said, like, if you have like a well, let's stay with Adidas, right? So if you have like a PowerPoint slide and it might have financial information, they say, like, how much, and it might only have the three stripes of Adidas on there, right? It's like, how much what was the revenue this year of like the company, that
Yeah.
it's that you need a multimodal model to infer actually from the logo
Yeah.
that the company refers to Adidas, because it's not in the text, it's in the it's inside. So those kind of things are super intriguing, but again, it is lowering that barrier to start building these kind of systems. So I have another question. I want to shift gears a little bit, because and again, this is a little bit of self-serving question, but I think people would love to hear this too. Um, so of course, Connor is talking to a lot of scientists in this space, right? So they have a specific modus operandi, how they they do the research, and how they how they bring that into to engineers, so that engineers can pick that off the from the academic information, and they can build systems around that. We have engineers; they have certain way how they build reliable systems. We had John to talk about like how we design systems for these people, but you are in more in like in the product space, and especially in the leadership space around that. So what's so interesting, and I'm in that myself as well, so that's why it's a self-serving question. The interesting thing is, like, you need to do a little bit of everything, right? So we touched upon in this in the 40 minutes we're talking, we talked about frameworks. You mentioned LangChain, Llama Index of this world. We talked about vector databases. So we talked about the models. We talked about the research that's happening. We talked about value capture and how we create value. So if something new emerges like this, right, like these LMs, what's your modus operandi? How far do you go in researching these things? Do you also try them out, or is just theoretical enough for you? How do you do that? How do you basically, how do you do your job?
Yeah.
What's your modus operandi?
Yeah, I think I'm lucky in that even at a very young age, like I absolutely remember the first time I saw a computer. It was actually probably that Commodore VIC 20, many years ago. And at that point, like as a kid, I was probably like 8 years old, saw a computer, and the kid and the 9-year-old or the 10-year-old who could make that computer do things seemed like a god to me. And at that point, my career path was set. There was no question that this is what I wanted to do for life. And so for me, a lot of that underlying thing starts with you just have to be genuinely curious about the topic at hand. Even if this entire industry didn't exist, even if it wasn't a well-paid job or whatever, I'd still be super fascinated and still super curious about what's going on at the frontiers of AI, what's going on at the frontiers of computing, enterprise service, or servers and clients and the web and so on, right? And so that's kind of the first mode of this, is you just have to come at it without any real agenda beyond I just am innately curious, and this stuff's fascinating. And there's an intellectual frontier that's being, that's being settled right now, and we're going to go off and try to get to that, get to that leading edge. The reverse side of it is like, I've spent most of my career in enterprise and selling things to organizations and large companies and so on. And so the reverse side of it's also there, which is at the end of the day, most enterprises, you kind of have to start with what are the use cases and what are the problems these guys are trying to solve with technology, right? The vast majority of enterprises on the planet are not technology vendors. The vast majority of them are companies that are trying to, provide mortgages to consumers, or, run nursing homes or something like that. And so you start with that problem that these guys are solving, and then you can apply a pretty tight razor to say, well, is this particular piece of technology going to be something that accelerates or decelerates or has no impact on what it takes for me to process a mortgage? Large language models, retrieval augmented generation, just to kind of chase that example, right? The vast majority of the content that's assembled and constructed inside of a mortgage package, which in the U.S. is now 300 to 500 pages per mortgage, is unstructured data, right? It's all different types of documentation and all different types of content that you are kind of going through the last X number of years of your financial life to assemble and provide to your mortgage officer. The decision they're making is a mix of both structured and unstructured data that they're using to ultimately evaluate that mortgage application. And so from that lens, you can come up with a pretty strong idea of, okay, what are areas that we think the LLMs and RAG and so on are able to accelerate? It makes it a lot easier to process things like a photocopy of a W-2 form, or look at checking account information, or look at read information about the property and so on. Other technologies, I'm trying to think of an example, but virtual reality or AR is unlikely to improve mortgage processing. Maybe there's some extreme example of it, but at least in the short term, it's hard to imagine that, right? Maybe it improves other industries, but certainly not some of the ones that I've spent a lot of time working with, things like financial services and so on.
Yeah, it's fascinating. I think looking at the fact that it's like early 2024 now. So if you had to make a prediction, if we record this podcast again like early 2025, no, let me rephrase the question. Not a prediction, but what do you hope to see solved? What do you hope? Like, it would be amazing if that would be solved.
Oh, interesting. A lot of what led to, I guess me working with you guys and working with the Weaviate team and so on. I do think the vast majority of language models deployed by the enterprise will have some retrieval augmentation. As I was mentioning, at least going into 2023, retrieval augmented language models meant a very specific thing, right? It meant a very large, frozen, high function language model coupled with a framework that's doing a lot of work, and then a vector database or some kind of a external repository to pull and get documents. I think different components of that architecture, we're going to start seeing a refactoring of that architecture, and different systems, different permutations of that, where some of the capabilities that we currently say are part of the framework become part of the vector store or become part of the language model. One scenario I didn't spend too much time on is like, there's the lost in the middle problem, obviously, today with a lot of large context language models. However, there's also a lot of research going into how do we address the lost in the middle, and how do we create massive language models, massive context windows, right? And so it's something like, you can imagine we're not too far from a world where if I ask a language model for a question about black holes, instead of just trying to go off and retrieve just information about black holes, we just give it the entire physics textbook and let it figure it out, right? So I think that entire idea space is going to get a lot of exploration over the course of 2024. I don't think it'll be one single architecture to rule them all, but I do think there's going to be strong convergence that at the end of the day, the parametric memory inside of the model will almost always need to be augmented by external memory that's provided via database.
Oh, that's super interesting. That is super interesting. So you might foresee the first glimpses of like a new architecture to really be implemented maybe this year.
Yeah, I think you kind of see those glimpses today, right? Like today, when people talk about the LangChain architecture, any of these framework-based architectures, you see that architecture today. Like all the functional elements are inside of that architecture. They're just kind of allocated in different ways and implemented in different ways. So things like content chunking today are extremely heuristic based and honestly kind of hacky. We're not far from a world where things like content chunking become a learned behavior and co-trained in conjunction with the embedding model, and then ultimately co-trained with the language model itself. And so, there's definitely some cool startups like contextual AI going after those types of scenarios.
Yeah, just to make sure that we're on the same page. So what you're saying is basically that now with the chunking, we say like, okay, we have, I don't know, a 20-page document, and then we chunk it up per paragraph. That kind of stuff. It's like that's going to be fixed in the model. You think?
Yeah, I think it's if any of you guys were involved in the early days of NLP, language tokenization used to be a very hacky thing, right? And then a bunch of people figured out how to solve language tokenization via a more modeled-based approach. I think you're going to see a similar modeled-based approach for a lot of the pieces of retrieval augmented generation.
That makes tons of sense. Yeah. Go ahead. Sorry.
Well, I think tokenization is an interesting one because we don't do end-to-end tokenization really. We mostly use like the byte pair encoding still, and so I guess I'm kind of not in the end-to-end camp. I really like, and this especially comes from the influence of talking with Omar Khattab about the DSPY framework or DSPy. I never get it right with how to pronounce it, but like this idea of like having programs where you have these different modules. So I think like instead of the architecture as like a transformer or mixture of experts, you think of like RAG as one architecture with retrieve and then generate. And then you add that like query rewriting part to it. Now maybe you put re-ranking in there, maybe you put summarizing before you answer, and now you've got like this program. And so to me, that was what, kicked off LangChain's growth, is this community sourcing of these pipelines. Like, hey, I have it write me an email, then I have an editor prompt, and then I have like a reviewer prompt. And so I think this kind of discovery of the programs is finally getting centralized around this DSPY framework. And, that's definitely what I'm like looking forward to working on is our Weaviate integration with DSPY.
Yeah, I mean, we're still in the earliest innings, right? These frameworks, and it's maybe even a little too harsh on like they are doing incredible work. And it's the power of open source. They have an incredible community. I mean, LangChain today versus LangChain 1 quarter ago are practically different products, right? And so there is it's hard to declare a winner in any of this stuff, right? Like there's teams and there's energy that are just doing incredible work. And we have some sense of what the long-term principles will be, right? The idea that memory is going to, more and more of the memory for a model or for a given task is outside of the model rather than inside of the model.
Oh, interesting. I'm actually curious to what the Connor, what your answer is to this question as well. What do you hope that by the end of, if we re-record this early 2025, what do you think or hope that will be resolved?
Well, I'm most excited about the LLM inference costs going cheaper and faster, because I want to see the generative feedback loops thing more, where my dream is like I do Google search of Vinod and Bob, and I get all the information, and then I have LLMs just like simulate conversations, create data. And I think that maybe we'll see a world where you have like your personal notes, and then the LLMs, like they do so much exploration within the ideas of your notes that it creates this billion scale vector index out of the product of the LLM, like thinking about your results, conversing with other LLMs that play different roles. And that's just what I really want to see, is the new use cases with absolutely massive vector search. I hope that's the particular one. I don't know if that particular, but just let's see 100 billion trillion scale vector search in that totally new use case.
Yeah, that's exciting. So personally, I hope that I was thinking about that, especially as a combination what you just mentioned, Vinod, and you, Connor, in cost going down, is that I'm always fascinated by this concept that the only way I can explain is like good enough, right? So that we get to a couple of these models that are good enough when it comes to inference, and then we try to, we have all these boosting algorithms, we have these ports that we have to see, and then the cost goes down. And I would not be surprised
on the good enough. That's, especially from a product standpoint. That is one of the classic kind of product strategy problems, right? It's like, so for example, I think we probably all agree that if you look at this stuff purely from an AI standpoint, end-to-end training almost always wins, right? However, there are other pros and cons of end-to-end training beyond just straight up performance of the model, and eventually you hit a point where that's good, your model performance is good enough, and it's these other secondary factors that drive you in one architectural decision direction or another.
Exactly, so to quickly finish that thought, I think so. I would not be surprised if the iPhone, where are we now, 14, but like 17 or Android, whatever. That's just for an iOS developer, an Android developer. That's just an API when they're writing code that just embeds that LLM, right? That they just basically say, okay, I'm now building something where I need something LLM based, or by then probably multimodal based, and that it just ships with the hardware. I would not be surprised if that's where we're going, and it doesn't really matter if it's like a proprietary model, or I believe so. For example, I believe that the Google model that Gemini has I believe it's called Nano. I might be wrong.
Yep.
That is built for that use case, so that it ships with Android. I think that's very exciting as well, because it's just going to be like ubiquitous, and what's going to be super interesting, of course, is that we're going to see like how will that interact with retrieval systems, and how will people be using that. So it's I hope that a year from now that's kind of common ground, that these models are not that they're just everywhere, and you get them in your phone, you get them on your laptop,
Yeah.
you get them in your fridge, and then it solves these fuzzy problems for you. This is great. This was a great conversation. It's a thanks for joining. If it was awesome.
Absolutely. Great to join you guys. It was a lot of fun. So.
Yeah,
Awesome.
fantastic.
Thanks so much, everyone.